All right, in our second exciting video about sequences and series, we're going to talk about recursive rules and more about series and summation notation. So just to go back to what we talked about in the last video, what we talked about was explicit rules. An explicit rule, we talked about the explicit rule for an arithmetic. An explicit rule will give you the nth term by putting n in, whereas a recursive rule will give you the next term in a sequence. So we'll kind of take a second to read through this stuff here. It just says putting n equals 5 into 3n minus 1 tells us that the fifth term is 14, which this is the sequence from up above. The terms in this sequence would be, I don't even know why I put this here because it's the same sequence as up above. It's the 2, 5, 8, 11, 14. And then what we're going to talk about now is the recursive rule for that series. The recursive rule is based on the term before it, which is called a sub n minus 1. Okay, and that's the term before a sub n. So actually, a good thing that we could put way up here by our definition of common difference is that the common difference is actually found by taking a term and subtracting the term before it. So you would take a term and subtract the term before it, a sub n minus 1. So that we can use that notation in order to define what the common difference is. All right, so here again is the explicit rule for an arithmetic series. The recursive rule would simply be to find a term, take the term before it, and add the common difference. The only issue with that is if I gave you a recursive rule with only this information, you wouldn't know where to start. So we also need to define a sub 1. I just put the number somewhere there. I usually use like a semicolon in between the rule and then what a sub 1 is. And then this is just to say, hey, just give what a sub 1 is. All right, so again, the arithmetic rule recursively would be that a sub n equals a sub n minus 1 plus d. And we will also give the first term. So this next example here is actually kind of a cross between both recursive and explicit, throwing everything at you at once here. So the rule here says that to find the term a sub n, take n squared plus 3n. So in other words, this is the spot in the series that we're talking about. So if we were looking for the fifth term, we'd be putting 5 in there. But if we were looking for the fifth term, we would need to know what the fourth term is for this piece right here, because that means the term before. So let's take a look at what this is going to look like here. We already know the first term is 2. Okay, that's given to us. The first term is 2. Okay. In fact, I'm kind of doing this all over here. The first term is 2. The second term, since we're finding the second term, n is 2. So n squared would be 2 squared plus 3n would be 3 times 2. But it says minus the term before it. The actual term before it is 2 as well, but it's from that 2. So what we would get there is 2 squared, so 4 plus 6 minus 2, that is going to be 8. All right, so now our next term, the third term, is going to be found by squaring 3 times 3, and then we're going to subtract, oops, that's not a good color to use, is it? Find the third term, squaring 3, multiplying 3 by 3, and then the next piece is putting the previous term in there. Minus a sub n minus 1, that would be the previous term, so 8. So now I've got 9 plus 9 is 18, minus 8 is 10. So we've got, what other kind of fun color can we use here? 10. All right, now we're going to find the fourth term. The fourth term is Fourth term is going to be 4 squared 16 plus 3 times 4, which is 12. So we're at 28 right now, minus the previous term 10. 28 minus 10 is 18. So really, they were asking us to find the first 4 terms of this sequence. So we have them there. They are the numbers 2, 8, 10, and 18. Okay, so notice this is not an arithmetic sequence. They don't go up by a common difference. It's a combination of both an explicit kind of rule and a recursive rule at that piece right there. Okay, now the next thing, actually the last piece of the sections 12.1 and 12.2 is going to be more about series. So remember, a series is when you add terms up. Okay, so that's why we've got not commas here, but all these addition signs. That's because we're going to sum up all these terms here. Remember, we have this notation called summation notation, which uses the Greek letter sigma. Sigma means to add things up or sum. Okay, so now what we want to do first is get some practice writing a rule, an arithmetic rule, and writing the summation notation here. So in summation notation, we want the rule for a sub n right there. Now that is always an explicit rule that goes there. Okay, so let's write a rule for that series. Notice that the common difference for that series up above is 9, because it goes up 9 every time. So the rule is going to be a sub n equals the common difference is 9, and the 0th term, if we went back 9, would be negative 15. And if you want to check that by using the formula, go ahead and do that. But that's what's going to go right here, 9n minus 15. Okay, this next piece is really important. When we are writing our sigma notation, our summation notation, we will always start with n equals 1 as our first input value. We have to, because in order to get that first term based off of the series, or the rule that we just made, it requires that to be 1 right there, because 9 minus 15 is negative 6. So if we don't start with a 1, we're not going to get that negative 6. So we start with a 1, and then we want to represent the summation of these 1, 2, 3, 4, 5 terms. Well, that means we want this to be a 5. Okay, so again, this means put in a 1, put in a 2, a 3, a 4, and stop, and you put in a 5. All right, well, we don't need to put those in because we already have the terms, but this is what this series would look like represented in summation notation. Both these things mean the same thing. These are both the same thing, just written in different ways. All right, so we could add these up. In fact, we'll take a second to add those numbers up real quick so you find out what the summation equals. If you added those terms up, you should get, what did I get there? 60. You should get 60 if you add those all up. Okay, but what if you didn't have 5 terms? What if you had 500 terms? Well, the cool thing is you can find a series, the sum of an arithmetic series, as long as you know how many terms you're adding up and what the first term and the last term is. Here's the formula we're going to use for summation of an arithmetic series. Okay, all you need to know is how many things are being added together. That's n. You need to know the first term. That would be a sub 1. And then you need to know basically what means the last term here, a sub n. So if we're finding the sum of 5 things, that would be a sub 5, or the 5th term. Okay. All right, so let's just do that with that series that we have up above. Let's see if we get 60 like we thought we should. So the sum of 5 terms in that series is going to be, we're adding 5 terms together, so 5 divided by 2. The first term is negative 6. The last term is 30. 30 plus negative 6 is 24. So 5 halves times 24, we can simplify that. Call that 1 and 12, so we basically have 5 times 12, which is, lo and behold, 60. We got the same thing as just adding those values up. So the formula works clearly. This would be a lot more useful if we had a large number of terms. But it's always going to be expected that you use the formula anyways. Even if we say, hey, add up 6 terms, we don't want you listing them all out. We want you to get used to using this formula. All right, so here's one where we have quite a few. We're not given the full series. We're only given the first 5 terms, and they want us to add up the first 30 terms. So remember, you need to know what the last term is. So you need to know what the 30th term is. We got to find that first, okay? In order to find the 30th term, we're going to need an explicit rule, not a recursive rule, because for a recursive rule, we would need to know the 29th term to know the 30th term. So we're going to need an explicit rule here. So let's come up with the rule. A sub n would equal, looks like our common difference is 3. And the term before that 4, if I went back, would be a 1. So 3n plus 1 is our rule for the nth term. So a sub 30 would be 3 times 30, which is 90, plus 1. So the 30th term is 91. Now we can easily find the sum of those 30 terms. Okay, now we're adding 30 terms. So we're going to take 30 divided by 2. And we are going to then multiply that to the sum of the first term, which is 4. And the last term, which we just found, was 91. So we have 15 times 95. And that is 1,425. So the sum of those first 30 terms is 1,425 without having to actually list them out and add them up. All right, now we need to interpret the series given this summation notation. So remember that as long as this is a 1, then whatever number is up there is what n equals. That's how many terms we're going to have. So we know that we are going to find the sum of 12 terms here. Okay? Let me just talk about that a little bit more here for a second. If this is a 1 and this is a 60, you can automatically know that you're adding 60 terms. Okay? So that's kind of the nice part about having a 1 right there. The reason is because remember, you're putting in 1 and then 2, so I'll just write n equals 1, n equals 2. You're going to do that all the way until you put 60 in. Well, 1 through 60 is 60 terms then. All right? So what if it's not a 1? What if this was a 4? And it said, add the terms when n equals 4 until n equals 60. Well, now, and I don't even know what my rule is for this example that I made up, but I know that the first thing I'm going to let n equals 4, and then I'm going to let n equal 5, and then 6, until I get to 60. Well, how many things would that be? Well, the way that you would find out the number of items that you have when you're counting is to take the last minus the first, and then add 1. Okay? So 60 minus 4 would be 56, plus 1 would be 57. Okay, why does it work that way? So this is what we'd be finding here is the sum of get rid of that one. We'd be doing the sum of 57 things in this case if we went from 4 to 60 for values of n. So why does that work that way? Well, think about, let's go back to when this was a 1. And I know that they didn't all right, we're going to go back to this being a 1. All right, if we went 1 through, I'll make this different now. Let's say I went 1 through 20. All right, if I did 1 through 20, clearly that's 20 things, right? If I said you have problems 1 through 20 for homework tonight, then you know you have 20 problems worth of homework. But using that formula that we talked about before, if I do 20 minus 1, that says 19. We know there's not 19 things, there's 20 things. So we need to, you know, oops, this isn't plus, this one, 20. All right, so there's not 19 things, there are 20 things. So what we need to do is add 1, because when we take 20 minus 1, what it does is it gets rid of, excuse me, that last value. So we need to add 1. to realize that there's 20 things. All right, so we'll practice one more like that. If I said, let's find the sum for n equals 3 to n equals 68, then how many terms are we adding up? Well, that would be 68, get rid of all this stuff. 68 minus 3 is 65, but we have to add 1. So that would be 66 then. We'd be adding up 66 things. So I'd have a 66 over 2 here, and then I'd have my first term plus my last term, whatever that is. Oh, actually, let's talk about that too. So whatever my rule is right here, okay, I'll just write the word rule. So I have some sort of arithmetic rule right there. Remember, this only works for arithmetic series. When I put 3 in, that's what this first thing is going to be right here, okay? Even though in our formula it says a sub 1, even though it says a sub 1 right there, it's the first term in your series. So in this series, if this isn't a 1 down here, then the first term is actually what you find by putting that in. So the first term in this case would actually be a sub 3. And then the last term would be whatever I get when I put in the 68 into that rule. So that would be a sub 68. All right, let's see that in action here now. So we've got 12 terms we know for a fact because n equals 1 then. So n equals 1 to 12 means we have 12 terms. So we're going to have 12 divided by 2 times. Now remember, the only thing, you don't need to find out what the whole series is. The only two things you need to put in are that, oops, we're not putting it there, that 1, and oops, you probably noticed this, but I have an I right there, and down there I have an N. The reason why I did that is because sometimes it's common to use an I instead of an N. So I'm going to change that guy to an I. All right. I'm still going to say that n equals 12 for the number of things. It's just that sometimes we'll use another variable here. So the first thing I'm going to put in here is 1. So I put in a 1, I get 2 plus 7, which is 9. And then the last thing I'm going to put in is the 12. So I put 12 in for I. 7 times 12 is 70 plus 14, 84. Plus 2 would be 86. So I know that if I did list this whole sequence out, I'd have 9, or let's call it a series because we're adding this together. And then the last thing would be 86. Those are the only two things we need. We add those together, and we multiply that by the number of things we're adding up divided by 2, which in this case is 6. So we're going to have some of these 12 things is going to be 6 times 95, which would be the same thing as 6 times 100 minus 30. So 600 minus 30 is 570. The sum of those 12 terms is 570. All right, so our last example here is going to be to use that same series from example 5, which is right there. And we're going to find out what the sum, or excuse me, what n would be in order to get 175 terms. All right, so here's what we're going to do for this one. We're going to take that formula. I'm just going to write that formula again right here. S sub n equals n divided by 2 times a sub 1 plus a sub n. All right, let's talk about what we know here. We know S sub n. We know that this thing is going to be 175. That is the sum. We know that the first term, because we're given the series, we know that that first term is 4. What we don't know are these two things. We don't know what the last term is. We have no idea. And we don't know what n is in order to get that last term. But the nice thing is we already have the rule. So the rule says that a sub n equals 3n plus 1. I can put that in for that a sub n right there. So here's what we have. 175 equals n n over 2, we don't know what n is, times 4 plus, okay, and then here's the important piece right here. We're going to use 3n plus 1 for n. And here's why that's the right thing to do. Because look at how we only have one unknown variable right now, just the n. So we can easily solve for that n. First thing I would do, actually we'll do two things at once here. We're going to multiply both sides by 2. Because when we do that, when we multiply both sides by 2, that 2 and that 2 would cancel out. And so we have now 350 equals n. And at the same time, what I'm going to do is distribute that n into this whole thing here. And we'll have 4, actually, let's be smart about this. Oops. We know that 4 plus 1 is 5, so this is 3n plus 5. And I'm going to distribute the n into that. So we're going to have 3n squared plus 5n. All right, let's get everything on the same side here. Subtract that 350 over. This equals 0. And now what we need to do is factor this guy here, or quadratic formula. I wouldn't complete the square on this thing. It is factorable. 3n and n is what we have to have in our first spot there. And then two factors of 350 that are going to end up working for us here are 10 and 35, because this gives me 35n, that gives me 30n. So if I make that positive and negative, I have positive 35, negative 30. That would add up to that 5n in the middle. So I would set these both equal to 0. But this one, right away, you could tell it's going to give me a negative value, and it's not even going to be a whole number. So we don't need that. That's an extraneous solution. This is the only solution that we need. Because remember, we're finding what n is. N is the number of terms you would add up. You have to have a whole number value as your answer here. So we know that we have to add 10 terms up in order to get a sum of 175.